Okay, this is going on page 135 and we're done. We have, on Friday, we converted between rectangular and polar coordinates. Today we are going to convert between rectangular and rectangular and polar equations. Okay, so not just the coordinates, but the equations themselves. Before we do that, we're going to do a quick little review up here at the top of a skill that we're going to need towards the ends of the notes. If I give you x squared minus 8x plus 6 equals 0, and we want to solve that, does it factor? No, because I would need two numbers that multiply to give me 6 and then combine to give me 8, and that doesn't factor, right? So this won't factor. If something won't factor, what are some options that you have to be able to solve it? Quadratic formula is one of them, so I'll tell you that, and that's fine, and that is one of them. We're not actually solving when we're in here, so that wouldn't help us with what we're doing today, but yes, that is definitely one of the options if you're trying to solve it. I need it to factor, not necessarily to solve it. What would another option be? Remember? Yes, completing the square. So we are going to have to complete the square. You probably, I would imagine that completing the square was introduced to you as a manner in which to solve, because you can totally use that to solve. But you also used it when you were just trying to get equations in a different form, whether it was a quadratic or it was a circle or something like that. So what we would do there then would be x squared minus 8x, and we would move the 6 over to the other side, so that would be equal to negative 6. Okay? So now I'm going to complete the square on the left-hand side, meaning I want a binomial that will square to give me whatever I end up on the left-hand side. So I will get x squared minus 8x plus something equals negative 6 plus something. Right? Because as long as I add it to both sides, I'm good. So what would I add to both sides? You remember what you do? 16. You take half of this and you square it. So half of negative 8 is negative 4. When you square that, you get 16. So you add 16 to both sides. My equation is still balanced. I've changed the way it looks. I haven't changed the value or the graph or anything else. Then when I actually factor this, this becomes x minus 4 squared. That's the whole point of doing that. And then that's going to equal to 10. That's you completing the square. Okay? So a little flashback there. Definitely something you did in Algebra 2. Okay? So we're not going to use that even on the front page, but that was the best place for me to put it as a little review there. All right, so let's look at what we are going to do on the first page. I'm just going to have to hold on to that in your brain a little bit. We're going to convert rectangular equation to a polar equation. It says to recall that x equals r cosine theta and y equals r sine theta. In terms of all of that stuff, what does tangent theta equal? Y over x. Okay, so we might use that too. You can work all of these without worrying about that, but sometimes that one just, it makes things a little bit easier. Alrighty, so let's look at number 2, the first number 2. There's two 2's because why not? So I've got x equals negative 3. Well, I know that x equals r cosine theta, so I substitute and I get r cosine theta equals negative 3. Then I need to solve for r, so I'm going to divide both sides by cosine theta, and I get r equals negative 3 over cosine theta. Well, what's 1 over cosine theta? Secant theta. So r is really just equal to negative 3 secant theta. And you're done. In the rectangular coordinate system, what does this graph? All lines are straight. Vertical line, and then this is also a vertical line, just in the polar coordinate system. We all good with that? Okay. So let's look at number 2. What would be the first thing you would probably do at number 2? Okay, you could substitute for y first. There's nothing wrong with that. Multiply both sides by 3. Divide by x. Okay, any one of those things is fine. How many of you would multiply by 3 before you would divide by x? You would divide by x first? Or is everybody okay with dividing by x first? And the reason I ask that is that it's fine, and it would make everything easier. But I don't want you making up stuff with fractions. So it's fine to divide by x first. I'm not going to do it that way, though, because I don't think everybody would. You with me? So I want to make sure that everybody knows what to do here, but you could definitely start by dividing by x. You can skip ahead of that if that's what you would do. But most of the time, those of you that are afraid of fractions are going to try and get rid of the fractions. So I want to show you that you can do that, and it kind of gives you an extra step, but it's fine. It's better than you making stuff up. So I do 3y equals x times the square root of 3. Now I have a couple of options here. I can substitute in for x and y, and that's fine. And I'll get sine theta, r sine theta on one side, r cosine theta on another side. But I also know that this is true. Could I get a y over x situation? Yes, I could divide both sides by x, right? And so I get 3y over x equals the square root of 3. Then I'd have to divide both sides by 3, so I'm just putting it back. That's why you could have just divided to begin with. Do you see how if we'd have just taken this and divided both sides by x, we'd have been good? Okay, you just got to make sure that you know. And that's when maybe you need to think of it as multiplying by 1 over x, and then maybe you wouldn't do weird things. I don't know. But y over x is tangent theta, so tangent theta is equal to the square root of 3 over 3. So theta is equal to the tangent inverse of the square root of 3 over 3. So what does theta equal? Pi 6. If you are going to graph this in the rectangular coordinate system, isn't this just a line where your slope is the square root of 3 over 3? Yes. And then this is a line that goes through pi 6 that would have that slope, obviously. Have that value then. Just two different ways to look at them. Any questions? All right. Let's look at number 3. So here we're going to substitute, right? We're not going to worry about getting the tangent or anything. And you actually could. It's just, it doesn't really matter. You end up kind of doing the same thing. So y is r sine theta. X is r cosine theta, but I have to square this. So I get r sine theta is equal to r squared cosine squared theta. Everybody with me so far? Now I'm going to divide both sides by r, okay, to get rid of those. So I get sine theta is equal to r cosine squared theta. And let me just make sure that you understand this is different than, you know, I showed you a quiz on Friday and I was like, you cannot divide out the x's, right? Made a big deal about that. And that kind of looks like what we're doing here. The difference is we're not solving this. We're cleaning it up. We haven't set it equal to 0 and trying to solve or anything like that. Okay, so we're just, you know, cleaning things up here. So now I need to get r by itself. So I'm going to divide both sides by cosine squared. So r is equal to sine theta over cosine squared theta. Does that give me tangent theta? Yeah, not just, but like it's not just tangent theta, right? Does that make sense? And we understand that because one of them is squared, one of them is not. So r is equal to sine theta over cosine theta times 1 over cosine theta. So what is sine theta over cosine theta? Tangent theta. And what is 1 over cosine theta? Secant theta. So what is this going to graph? Going to be a line? How would you know without actually graphing it? It's a parabola. Isn't this a parabola? So this has to be a parabola, right? You haven't graphed it yet, but remember they're going to give you the same thing, so it's a parabola. Okay. All right, you work on number 4. Any questions at all? See if you agree with what I have. And there are some steps that you could kind of skip through. Like, be careful skipping too many steps, just because even when you feel like you have a good grip on it, it's easy to think something's going to happen that doesn't, and when you kind of skip that step, it just makes you not sure that you understand it. But there's ways to clean that up. In your notes, I want to make sure I don't miss anybody. I also think in your notes, it's good for you to have all the steps written out too. That way, if you go back to it, a little while from now, you're not looking at your own notes going, how the heck did I get that? I mean, how many times do you get your work back and you're looking at your own work that you did not too long ago and you're like, what the heck? Where did that come from? And you can't figure it out. So the more steps you have shown, the better when it's something you might refer back to. All right, any questions? All righty, let's look at number 5. We are going to substitute. So I'm substituting for x. This is going to be r cosine theta, and that's going to be squared, plus r sine theta, and that's going to be squared, and that's equal to 16. So this is going to be r squared cosine squared theta plus r squared sine squared theta equals 16. Now remember, our goal is to solve for r, and so I have two terms that have r's in them, and I cannot combine those two terms. But what can I do on the left-hand side? Factor out GCF. So r squared times cosine squared theta plus sine squared theta equals 16. Well, what is cosine squared theta plus sine squared theta? 1. So that means that r squared is equal to 16, and we're done. You don't even have to take the square root. You can, and it's fine, but this is good enough too. So r is really the plus or equals plus or minus 4. What would that graph in the polar coordinate system? If I just it's just a circle, right? Isn't this the equation of a circle? This is the equation of a circle with the center at the origin. So is that. Radius is 4. Okay, we good? All right, so I want you to work on number 6, and I also want to let you know that when you substitute this in, and you're going to square it, and it's just by itself squared, there's nothing wrong with starting with r squared cosine squared theta. I just didn't want to do that too soon, so you didn't think magic was happening somewhere. And then that's equal to r squared sine squared theta plus 1. Okay. So get your r's together on one side. See if you can get r by itself. So cosine squared theta minus sine squared theta, does this give me 1? No. Does it give me something? Yeah. What does it give me? How would you know? Staring at me isn't going to get you anywhere. Don't yell stuff out. Actually look for it. On the blue one I gave you would be the best. It has all of them on it. Those little teal ones on your table that might be left there, they're not on it. But your reference sheet, if you don't know what it is, which it's okay if you don't know what it is. Like when you add them, by now you know that's 1, right? I didn't make you memorize that. You just know it because you've used it so much. This one we haven't used that much, so you don't know it. So you got to be able to know where to find it. Cosine what? Cosine 2 theta. So this is cosine 2 theta. And that equals 1. Still got to get r by itself, so I have to divide. So I get r squared is equal to 1 over cosine 2 theta. And we can't leave that in the denominator, so what's the reciprocal of cosine? Secant. So r squared is equal to secant 2 theta. And it's okay to leave it as r squared. Everybody good so far? Flip it over. Let's look at number 7. All right. So eventually, this thing is going to have to actually get squared. You could do it now. You could do it after you substitute. I suggest you do it now, because now you're using x's and y's, you're not using trig stuff, it just makes it better. So when I square this, is this going to give me x squared plus 1? No, it absolutely is not. It gives me x squared plus what? 2x plus 1 plus y squared equals 1, right? So then if I subtract 1 from both sides to clean it up, I'm left with x squared plus 2x plus y squared equals 0. So now is when I'm going to substitute, because I've cleaned it up as much as I can without that. So this x squared becomes r squared cosine squared theta plus 2r cosine theta plus r squared sine squared theta equals 0. So now I'm going to take everything that has r squared in it and leave it on the left-hand side. Everything that doesn't have r squared, I'm going to put it on the right-hand side. So this is going to leave me with r squared cosine squared theta plus r squared sine squared theta equals negative 2r cosine theta. On the left, I have a GCF again. So r squared times cosine squared theta plus sine squared theta equals negative 2r cosine theta. So here I have cosine squared plus sine squared. What does that give me? 1. So I have r squared equals negative 2r cosine theta. So this one I can't leave an r squared though, because there's an r on the right hand side. Divide both sides by r. R is equal to negative 2 cosine theta. We good? Questions? All right. You start working on number 8. Number 8. Once you get it all substituted in and set equal to 0, then do basically the same thing we did on the other one. Move everything that doesn't have an r to the left, everything that does have an r to the right. Legally. Then you have something you can factor out on both sides. On the right-hand side, though, it doesn't have to be the GCF. If you did, it's fine. There's nothing wrong with it. All I'm really concerned with is r, and so it doesn't really matter either way. This cosine squared theta plus sine squared theta gives me what? 1. So I get r squared equals r times 4 cosine theta minus 2 sine theta, which means r is equal to 4 cosine theta minus 2 sine theta. If you have 2 parentheses, 2 cosine theta minus sine theta, it's fine. Like if you had actually factored out the GCF, it's fine either way. Any questions at all? We good? All righty. And so both of those things graph circles. The circles just aren't at the origin. All right, let's look at converting from polar to rectangular. We have r cosine theta equals x, y equals r sine theta, r squared equals x squared plus y squared, but we're also going to use r equals the square root of x squared plus y squared. It just kind of depends on the situation you're in, so just remember you could use either one of them. We know that tangent theta equals y over x, so that means that theta is equal to the tangent inverse of y over x. Alrighty, so number 9, r equals 7. Well, what do I substitute in for r? Square root of x squared plus y squared, right? So the square root of x squared plus y squared equals 7. Square both sides, and I get x squared plus y squared equals 49. This is a circle centered at the origin with a radius of 7. So is this. They were just in different coordinate systems. Okay. Everybody good with that? All right, number 10, theta is equal to 2 pi thirds. Well, theta is the tangent inverse of y over x. So the tangent inverse of y over x is equal to 2 pi thirds. So I need to get y over x out of that. What's the opposite of the tangent inverse? Tangent. So I take the tangent of both sides and I get y over x is equal to the tangent of 2 pi thirds. What is the tangent of 2 pi thirds? Negative square root of 3. I want to get x by itself, multiply both sides by x. Y is equal to negative x square root of 3. This graphs a line with the slope of a negative square root of 3. So does that. Everybody good? Any questions at all? Alrighty, on to the next one then. Here I have r equals 3 secant theta. Now, I do have something I can substitute in for r. It's x squared of x squared plus y squared, but that doesn't do anything with my secant theta. Like, once I substitute, I need to have everything in x's and y's eventually. I have nothing for that. So instead, I need to try and make it look like something I have up there. So r is equal to, what's the reciprocal of secant? Cosine. So this is 3 over cosine theta, right? So I do have something up there that has cosines in it, but it has to be r cosine theta. Well, if I multiply both sides by cosine theta, then I get r cosine theta equals 3. Well, what's r cosine theta? X. X equals 3. This is a vertical line. So is this. Those reciprocals by themselves, those are lines, right? We good? Do number 12. Y equals negative 2. Easy enough. All right, so let's look at 13. On 13, on the right-hand side, can I change that to 2 times y? No, because that is not r sine theta. That is sine theta. If I divide both sides by sine theta, then I have r over sine theta, which does not match any of that stuff either. So here's, up here, when we were cleaning this up, you know how we divided these r's out? We divided the r's out. Basically, we need to put them back. So I'm going to write one step that I totally would not expect for you to write in your actual work when you're working it, but I want you to write it on this one so that you remember what we were doing here. So I'm going to multiply both sides by r, so that I can get that r back in that basically we would have taken out if we were going the other way. Okay, so I multiplied both sides by r. What that's going to give me is r squared equals 2r sine theta. Okay, so I just introduced that r back in there. So r squared I can replace with x squared plus y squared. That's equal to 2 times r sine theta is y, so this is 2 times y. Everybody good with that? So now I'm going to set it equal to 0. And I get x squared plus y squared minus 2y equals 0. Well, I need it to look like the ones in 7 and 8, like what they originally gave me. That's my goal. So I need a binomial squared. This is why we have to complete the square. Because now I'm going to have x squared plus y squared minus 2y plus something equals 0 plus something. Right? And all I'm trying to do, because the x is by itself, it's squared. It's this that I'm trying to complete the square with. So what goes in my blank? 1, right? Half of negative 2 is negative 1. I squared, I get 1. 1 and 1. That means what I end up with is x squared plus y minus 1 squared equals 1. There's my circle, the center at 0, 1. Any questions? All right, you do number 14. Any questions at all? See if you agree with me. Because if I factor this, it's plus 3. It's positive. Okay. Anything else? And if you look back up at 7 and 8, when we multiplied the stuff out in the first step, and then we subtracted, we cleaned it up and we subtracted the constants from both sides, do you see how they disappeared each time? That's because basically they're gone, and so we've got to put them back in there by completing the square to get it in this form. And again, you did this kind of stuff in Algebra 2 so that you could get it in this form. It may have been just for a quadratic, just to get it in whatever form you were trying to get it in, or even circles when you did that. Okay. Any questions at all? Alrighty, so go ahead and get it put in your ISN. Your assignment is one-sided again, so get started on it. Shouldn't take you too terribly long.